After some technical difficulties, we're back with section 2.7, linear functions, intercepts. So these last three sections of this second chapter all deal with linear functions. So we're going to talk about intercepts, then we're going to talk about slope, then we're going to talk about equations of lines. So the first thing we have here is the general form of a linear equation in two variables, which can be written as ax plus by equals c. So since we just did this section on formulas, we can actually think of this as a formula or a literal equation, and we want to try to solve it for y, because if you remember from the first unit, when we were dealing with input-output rules, they were always in the form y equals. So we're generally going to want to do the same thing with linear equations in two variables. We're going to want to solve them for y. So in this case, if we have ax plus by equals c, and we're solving for y, similar to what we did with formulas, we want to get rid of this ax, which isn't attached to the y, so we can get rid of that first by subtracting ax on both sides. So we would have by equals c minus ax, and then what we could do is get rid of this b by dividing both sides by b, and again we are dividing this whole side by b, so that's two terms. So that's one way to write it, right? You can write it as y equals c minus ax all over b, or you could separate it, and generally separating it is the way that we're going to want to do it for the most part later on when we do slope intercept form. So it's probably easier to write this as c over b minus ax over b, right? You see how we're just dividing both of the terms by b. So either one of these would be acceptable. So generally speaking, if we take a linear equation in two variables and create a table of values for it, we can get a list of solutions to the equation that you can then write as ordered pairs. And then if you graph those ordered pairs, they should form a straight line. So same thing with this, 2x plus 3y equals 6. This is not in a good form for us to finish this table with, right? So we probably want to take this equation and do the same thing we did with the one above. We probably want to solve it for y. So we'd have to subtract 2x, right? So we have 3y equals negative 2x plus 6. And you see how I'm switching the order? Because generally that's the order that we're going to want to write it in. Going forward, we're going to want to write the x first, and then you're going to want to divide by 3. So here we end up with y equals negative 2/3 x, and then 6 over 3 is 2, plus 2. So this is not a great input-output rule, or, you know, that's how you can think of it. You can think of it as an input-output rule because we have this negative 2/3 here. So it's going to be a little tricky now. So when we plug in a -1, and you just take my advice on this, take my word for this, that I'm getting the right answers. So it's 8/3, 2, 4/3, 2/3, and 0. So now what will happen is if I try to plot these points, I can't plot them all accurately because most of them are fractions, but the two that you can plot accurately would be 0, 2, and 3, 0. So 0, 2 is going to be here, and then 3, 0 is going to be here. And then what you'd want to do is you just want to draw a line that connects those points, right? 0, 2, and 3, 0. And then you can probably see that it also goes through 1/4 and then 2/3, so on and so forth, right? I mean, it's not exact, but close enough. But really, the reasoning behind doing this was to identify these points here. And what are those points? 0, 2, and 3, 0. Because those points are special points, and those are going to be known as the intercepts. So that point 0, 2 is known as the y-intercept because it's where the line crosses the y-axis. And the point 3, 0 is going to be known as the x-intercept because it's the point where the line crosses the x-axis. So really the important thing to note about the intercepts is the y-intercept is the point where x equals 0. And the x-intercept is the point where y equals 0. So that's really the most important thing to understand about intercepts. When you're trying to find intercepts, what you just do is you just set one of the variables equal to 0. So to find the y-intercept, you let x equal 0, and to find the x-intercept, you let y equal 0. And that's going to work for any line that we deal with. Okay, so just a quick example here of this is if we have 3x minus 4y equals 12, and we're trying to find, let's say first the x-intercept, I guess, right? Oops. So the x-intercept is going to be the point where y equals 0. So what we're going to do is we're going to rewrite this equation, but where we see the y, we're going to put a 0. And then what happens here? That's beautiful. 4 times 0 is just 0. So that just falls away, and then we just end up with 3x equals 12, and then we can just easily divide both sides by 3. So we would get x equals 4. And again, remember, this is a point. This is the most important thing to understand here. Intercepts are points. They're not just x values. So this x-intercept is the point 4, 0. Right? It's a coordinate, an ordered pair, a point, 4, 0. And then you'll do the same thing to find the y-intercept, but this time you will replace x with 0. So I'm going to rewrite the equation, but now where I see x, I'll plug in a 0. So again, similarly, 3 times 0 is 0. That just falls away. So you've got negative 4y equals 12. And then if you divide both sides by negative 4, you'll get y equals negative 3. But again, this is an ordered pair. Y is negative 3, x was 0. So it's the ordered pair 0, negative 3. So that would be your y-intercept, right? And then this is actually the first way that we can graph lines, right? Just find the intercepts and then connect them. Because if you ever want to graph a line, you really only need 2 points. So I have 2 points, 4, 0, 0, negative 3. If I wanted to graph that line, just plot those points, connect. I'm done. Which is basically what I just did before with the graph, right? I found those intercepts and just connected them. So that's actually the first method that we have of graphing lines, graphing by the intercepts.